This is so much fun. I'm so honored that I get to speak and, more than 5 stars. That's pretty cool. We're going to talk about a service mesh. But before we do so, here's the part where I tell you I am definitely going to post the slides on my site tonight. You're going to hit, uh, you'll hit my site tonight, tomorrow. I've been that guy chasing the speaker as well, and it never worked out very well, which is why you can go to robrich.org right now and click on presentations. Here's service mesh to service mesh. Actually, let me cruise up to the BSides Knoxville. Service mesh to service mesh. Here is the slides. They are online right now. Achievement unlocked. Woohoo! Okay, while we're here on robrich.org, let's click on About Me and we'll talk about some of the things that I've done recently. I'm a Microsoft MVP, a friend of Redgate, a single store developer evangelist, and let me tell you about AZ Give Camp. AZ Give Camp brings volunteer developers together with charities to build free software. We start building software Friday after work. Sunday afternoon, we deliver that completed software to the charities. Sleep is optional, caffeine provided. If you're in Phoenix, come join us for the next AZ Give Camp. Or if you'd like a Give Camp here in Knoxville or wherever you're connecting from, hit me up on email and Twitter, and let's get a Give Camp installed in your neighborhood too. Some of the other things that I've done, SQL Source Control Basics, mine is Chapter 8. That was really fun. And one of the things I'm particularly proud of, I replied to a .NET Rocks podcast episode. They read my comment on the air, and they sent me a mug. Woohoo! And if you'd like it, no, I'm just kidding. Service mesh to service mesh. Let's dig in and start talking about what is a service mesh? Why might I try to use it? But first, do you remember when you learned how to drive? Do you remember that freedom when you expanded beyond your current neighborhood and you were able to travel across town or maybe between towns? You know how fun it is to be able to drive on an open road? So let's imagine we're in a small town and we're able to drive as fast as we need to get where we need to go, and it's really, really fun. Well, in time, the town grows up and we start having traffic jams. So how do we solve this? How do we get, well, I've looked at this graphic and I'm like, well, so I think that this guy needs to turn, maybe this bus can, this guy might have the right idea. Maybe if we can, not solve this, but how do we solve traffic? Well, okay, let's put a traffic cop at the edge of town and he'll be able to monitor it. Anybody who's speeding on the way into town, he's gonna slow them down. Now that's great, but we're not getting to where we need to as efficiently as possible now. Instead, we're getting to uniformity. We're all traveling the same speed. So those people who want to travel slower or faster are actually getting a less effective experience. Really what we want is a mechanism where the cars can communicate with each other, where we can prioritize traffic. Those cars that want to go really fast or emergency vehicles can use expedited experiences to get where they need to go fast. And those cars who would rather enjoy the scenery and meander can definitely do so. When we're working together, we can ensure that we get as efficiently as possible, rather than just focusing on uniformity. Let's use those same principles as we start looking at a service mesh. We'll take a look at what is a service mesh? Why would I want it? What other things exist in this space? What problems are we trying to solve? We'll look at both Istio and Linkerd, both great service meshes, and finally kind of look at what are the trade-offs? Why would I want to choose a service mesh or not choose a service mesh? Let's dig in. So first up, a service mesh. It manages network traffic between services inside of a Kubernetes cluster. It's a great answer to the question, how do I observe, secure, and control the traffic in my Kubernetes cluster? Now, as we dig in here, let's look at observe, secure, and control. Now, a service mesh is going to watch the traffic moving between each microservice. As we look at the traffic moving between the services, we can understand, well, what is the network topology? Let's level up and talk about control. Once we've identified which containers call which other containers, we can say, maybe it shouldn't. Maybe we have a microservice reaching into somebody else's database. Let's create policies to be able to ensure that only those approved services are able to communicate together. And if we start a rogue container, well, it's locked out of everything. And finally, secure. Let's create mutual TLS between our services. Now, typically when we talk about mutual TLS, we talk about a trust chain, we talk about verifying the trust chain, and we talk about all of the weight that we need to add to our applications. What if we could do that outside of our applications in the service mesh instead, but still achieve that level of security? Observe, control, and secure. That's what a service mesh will give us. On the left, we have a monolith. On the right, we have microservices. Now, why did we start out with a monolith? Well, deployment was hard, and we chose a monolith so that we could be able to get all of our content deployed in one big bundle because, well, deployment was hard. On the upside, all of our private network calls, all of our private method calls are just local to our executable. They're just memory addresses. As we move towards microservices, we can scale each service independently. We can deploy much more frequently. Containers have made it possible for us to achieve this really elegant distributed system. So here on the right, we have microservices. And well, now that we're deploying quickly, we get great scale, but well, our internal methods now have IP addresses. Do we really want to call into each method straight away? As we look at the traffic flowing through our Kubernetes cluster, we'll look at two different kinds of traffic. We'll look at north-south traffic and east-west traffic. North-south traffic flows into or out of our Kubernetes cluster, where east-west traffic flows between the microservices within our cluster, between the containers. Now, the cool part is that a service mesh can handle both north-south traffic and east-west traffic. So what came before? Well, before we had a service mesh, when we just had a Kubernetes cluster, we wanted that mechanism that, well, the traffic cop at the edge of town. Let's find all of the rogue traffic coming into our cluster and ensure that it doesn't get through. That API gateway is a fence around our cluster. It's great at being able to stop north-south traffic, but it's only a fence around our cluster. What about that east-west traffic? Now, in this case, notice how this microservice that owns this data source is actually reaching into the other data source. Now, this microservice owns that data source, and we shouldn't be able to call into it. The API gateway can't stop us here. The API gateway is merely a fence around our cluster. Now, it's great for monetization and accounting. Let's count the number of requests that you make and be able to bill you for those requests, or ensure that you're authenticated before you enter. But once you're inside the cluster, that east-west traffic, an API gateway really can't help us with that. So let's level up. How does a service mesh work? Let's create a service A, and service A wants to connect to service B. Now, without a service mesh, service A would just open a network connection, connect to service B, and call it. With the service mesh, it's a little bit more. Inside the service mesh, we will deploy a sidecar proxy along with each container inside the same pod. So here's a local network boundary that includes both the service and the sidecar proxy. So if service A wants to communicate with service B, service A will reach out to its proxy. Now the proxy is going to go check in with the service mesh control plane. Am I allowed to call service B? In this case, the control plane says yes. And so service A creates a connection to service B's sidecar proxy. Service B's sidecar proxy again checks in with the service mesh. Am I allowed to accept connections from service A? In this case, the service mesh says yes, and it forwards that traffic on to service B. Service B processes the result, and the result flows back to service A through that service mesh. Now, what's beautiful here is that the proxy is able to connect to the other proxy using mutual TLS. So we'll use a certificate on this side and a certificate on this side, and the trust chain goes through that service mesh. The service mesh can define that trust chain and ensure that all of that traffic is encrypted. Pardon me. So we have this elegant mechanism where service A can go through its proxy, validate with the service mesh, call out to service B's proxy, validate with the service mesh again, and forward the traffic to service B. This pod boundary ensures that only local traffic is able to proceed unencrypted, and all of the traffic between containers is encrypted with mutual TLS. Now that's wonderful. As we look at this methodology, we now have the ability to watch all of the traffic flowing between our services. Let's observe that traffic. Now, as we notice that traffic pattern, we can start to control that traffic. Should we be able to call that other service? Should we be able to accept traffic from that other service? If not, then we can block that traffic. And then finally, secure. We created mutual TLS between these two services without impacting our code base. That is immensely powerful. Just create your services using HTTP or gRPC or protobuf, and we'll be able to secure that over this HTTPS connection and flow that traffic through. Observe, control, and secure. Now what's really cool is the service mesh is not just that first level of being able to proxy traffic between things, but we can also level up and get some advanced features around this experience. Because we're proxying traffic between all the services, we can do things like network topology diagrams. Now, what's interesting is that we're watching the traffic flow between services. This is not what the developer thought would happen. This is what's actually happening. Now, that's really powerful because, well, we can compare that to the developer's view of the architecture and see, hey, did you hard code that configuration value to point to the wrong database? We can see that based on the network topology diagram. We can take a look at service health. We're looking at all of the requests and responses so we can keep track of status codes and response times. Is this service responding much more slowly than it did? Is this service throwing 500 errors more than it usually does? Finally, we can log all of that content so that we can start to observe our cluster much more closely. Is this usual behavior? Does it often spike on Monday at 3 p.m.? Observe, secure, and control gives us the ability to create these advanced scenarios. Let's level up again. While we're observing, securing, and controlling the traffic, we can create different usage scenarios. For example, let's create an A/B test where we'll send 50% of our traffic here and 50% of our traffic there. Now this service mesh, this sidecar proxy, can go check in with the service mesh control plane and understand which service it should point this request to. So it's easy for the control plane to say, well, I'm going to send you this direction or that direction. We have an A/B test. Or we can create a beta channel. Let's create a mechanism where early access customers can use the beta versions of our software, get early access to features, help us understand the health of those systems. And once we have a little level of confidence here, we can roll it out to the main audience. Together, we can create circuit breakers. Now, it's really easy when a dependent service is struggling for us to, well, the first thing we're going to do is retry those connections, which ensures that we bury the service. If there's a service that's teetering on the edge and the clients start retrying all the connections, it's going to go down. So we can trip the circuit breaker. Once the circuit breaker is tripped, then we'll just fail all those requests straight away. We can give the service a chance to regain health, to start back up, to initialize itself and get to a healthy state. And then we can start slowly flowing that traffic back in. Now, unlike a circuit breaker where you have to go crawl around to the panel and push the button, with a circuit breaker inside of a service mesh, we can automatically turn it back on when the service is healthy. Now this is really cool. Circuit breaker, A/B testing, beta channel. Because we're standing in between all of the service connections, we can create these advanced network traffic patterns. We also have great dashboards associated with a service like this. So here's a Grafana dashboard and a Keali dashboard. Let's dig into those. Any questions before we dig into demos?
Rob, I'm not seeing any questions.
Perfect. Well, on our way into demos, let's take a look at one of these things. As we look at a service mesh, we want to make sure that we don't have unexpected traffic patterns. Because we have those sidecar proxies, then this microservice is never going to reach out to the other database. Now, we do need to work with our developers to ensure that they don't code their application that way, but that's one of the benefits here of a service mesh is routing traffic correctly. So now let's look at various service meshes. Now we're going to demo Istio and Linkerd today, but let's take a look at lots of service meshes. Istio, Linkerd, Console, Open Service Mesh, Dapper maybe. And let's take a look at their characteristics. Now we could look at their feature sets, but they're always one-upping each other. So for the most part, the feature sets are pretty consistent across them. So why would I choose one over the other? Let's instead look at methodologies associated with each service mesh. The comparison between the methodology of Istio versus Linkerd. So first up, Linkerd. Now Linkerd is great at being able to build out their own ecosystem. They're a great contributor to the Rust network stack because they kind of build all the things themselves. They do include a few external packages, but for the most part, they focus on a really elegant startup user experience. Now that's great. We get a great startup user experience, but if you want to climb outside the standard path, you'll need to use some plugins. Now they kind of go back and forth about, are they going to use Envoy as their proxy or their own built-in proxy? The difference between Linker 1 and Linker 2, for the most part, is that. Are they using their own proxy or an external proxy? But it still has that same methodology where we end up with a sidecar proxy that checks in with the service mesh control plane to do what it needs to do. By comparison, where Linkerd focused on having a really smooth startup experience and writing everything themselves, Istio focuses on combining the best open source packages together. So with Istio, we have profiles where we can say, here's the profile. I want to focus on minimum install, or I want to focus on ensuring mutual TLS, or in the one that we'll use today, the demo profile where we have everything turned on. With everything turned on, we have access to lots of dashboards from third-party utilities, Jger and Grafana, and all kinds of really interesting things. With Istio, we can turn those profiles on and off to be able to enable features, or we can get in and turn specific features on and off. Istio is more of the kitchen sink approach, where Linkerd is more of the lightweight approach. Now, ultimately, they both have sidecar proxies. They both have mechanisms for checking in with the control plane. You can observe, secure, and control using either one. So let's demo both of them because this will be really fun. I have a cluster right here, a Linkerd cluster. Let's use that. And let's fire up the Linkerd install experience. Linkerd viz install kubectl apply -f dash. Now I've taken a few liberties here. As we go to Linkerd's getting started page, we'll start off by grabbing the, let's double check that our Kubernetes cluster is running. Then we'll go grab the Linkerd CLI. Once we've got the Linkerd CLI, we can verify its version. And then we run Linkerd check --pre. That will validate that Linkerd will install correctly on our cluster. Next up, we'll go grab Linkerd install, pipe it to kubectl apply -f. And so basically that will spit out all of the custom resource definitions, the CRDs, associated with Linkerd. I've done that previously. Next up, we'll do a Linkerd check and make sure all of those things are in place. And finally, we can install some visualization dependencies, Linkerd viz install. And so that's what I've done just now, Linkerd viz install, and we've got all of those things created. Next, we can do a Linkerd check, and this will go validate all of the pieces of our cluster. So it looks like our cluster is ready to go. that was great. The install experience with Linkerd is really smooth. And that Linkerd check is really elegant at being able to find the details of our cluster. Now that we've got Linkerd started, Linkerd Viz dashboard, let's take a look at, helps if I spell Linkerd correctly, Linkerd Viz dashboard. Up pops the Linkerd dashboard. Now we can take a look at our namespace. Let's look at the Linkerd namespace. And with each of these deployments, we can take a look at the details associated with that deployment. Now in this case, the deployment hasn't been running very long, so there isn't much there. But if we dig into, for example, this container, we can fire up the Grafana dashboard for this particular deployment. Here's some metrics around our cluster to be able to see how it's running. Yep, that's the point where I turned it back on. And now we get a Grafana dashboard showing us the details of this cluster. Now what we notice is that Grafana is pretty much the only external package that we have visible here. This dashboard is, for the most part, all Linkerd created. Now we don't necessarily need to click through everything to get at it. Let's come back to our console and let's say Linkerd viz stat, and I'll do it for the Linkerd namespace. And let's take a look at the deployments. No traffic found. Because I spelled Linkerd incorrectly again. There we go. So we get those same statistics from the command line. We could use this to scrape those details, or we could hook up a Prometheus sync to be able to grab the metrics out of our control plane and push them into another dashboard. Linkerd focused on getting that install experience going really quickly. Let's turn off Linkerd and let's instead focus now on Istio. So I actually have two different clusters running, an Istio cluster and a Linkerd cluster. So flipping over to the Istio cluster, let's take a look at Istio. Now, one of the things that's interesting about Istio is the getting started experience is quite similar. I grab the Istio command line. I can check out the Istio version. When I start to install Istio, I'm going to first pick my profile. In this case, it's the demo profile, which is the everything on profile. And then I can start to add annotations to my particular namespace. So let's do that. Let's annotate the default namespace with the Istio injection equals enabled tag. Now that means that any of, I've already got it set. Any of the pods scheduled inside this namespace will get that sidecar proxy. Do I want to exempt a namespace and not control it? I can just leave this tag off of that namespace. That's perfect. Once I've got this running through, they do have a great sample application that I've already got installed. Let's take a look at that sample application and let's go grab the port that it's running on. kubectl get service, Istio ingress gateway in the Istio system namespace. And it looks like we're going to look on port 31100. So if I load this application here on 31100, I will get at a product page. Now, the interesting thing about this product page is there's a bunch of microservices happening. There's a microservice for book details, there's a microservice for book reviews, and there's a microservice for the number of stars that we should show. Here's a network diagram of that application. Here's our product page, and it'll call out into the details service to get that content here on the left, and it'll call out to the reviews service to get the content here on the right. Now, depending on which version of the reviews service that we use, we might get stars colored in black, stars colored in red, or no stars. For those that show stars, we'll call our rating service to get the number of stars that we should show. So right now it's set to equally go between those three ones. Here's stars in black, here's no stars. If we hit refresh enough, we'll probably get stars that are red. No, there we go, stars that are red. So we have those three versions running simultaneously. Now, in a normal scenario, we would probably only run one version at a time, But in this case, having all three versions will allow us to highlight in Istio the way that we can transition between versions really seamlessly. Here I have a list of versions. So here's that virtual service that I have routed, and right now it goes equally between these three destinations. So let's switch over instead to virtual service reviews version 1. Now, at this point, let's assume that we've installed version 1 of our service, and we want to cut over all of that traffic to just this service. Okay, now we've gone to version 1. If we push refresh on our page, we'll see that we now no longer have stars at all. Okay, so I've readied my deployment, I've built my container, and I'm ready to cut over to version 2, but I'm not quite sure about it. Let's see, do we have enough content in place? Do we have the right validation parameters in place? Will our content scale? So let's come in here and say, let's go between our service, 80% to the old service and 20% to the new service. Or we could even take a much more conservative approach and say 90% to the old service and 10% to the new service. Let's just take a small portion of traffic and move it to the new one. Copy that. kubectl apply -f, that one. Now there's no downtime because both of our containers are already running. We're just telling the control plane, hey, when the sidecar proxy checks in and says, where is the rating service? Point them at this one instead. Okay, so back on our page. Now, most of the time we will get no stars, but every now and again, we'll get stars colored in black. There we go. Now we may choose to use sticky sessions or another mechanism to be able to transition users over to the new version. But ultimately, once we've decided that this version is good, let's flip all the way over to V2. Now with V2's service, we can see that we go all the way to version 2. No downtime, we're just pointing the service discovery piece, and now we always have stars colored in black. Okay, so now let's get ready to do version 3. Now here I have version 3, but I want to do a canary release. I want to have a beta channel. So in this case, for the user that is authenticated as Jason, then I'll give them version 3. For everyone else, I'll give them version 2. Now we might want to do this based on an authentication header or another mechanism, kubectl apply -f. So now we've got the majority of our users using version 2. I'm going to consistently get the stars colored in black. But now let's sign into our site. I'm going to sign in as Jason and log in. Now that I'm authenticated, I get stars colored in red. I'm able to check out that beta channel and understand the content in this system. Let's log out again. And now we're back to stars colored in black. We're back to version 2. Okay, I've fully tested my application. I'm ready to go to version 3. And so let's flip over completely to version 3. Now here with version 3, we see that we've got 100% scroll. Okay, let's go this way. So now with version 3, we see that we have 100% of our traffic moving to that new version. That's great. Now let's refresh it and we will always get the red stars. That was really cool. We got to see an upgrade going from version 1 to version 2 to version 3 with no downtime at all, using just the intelligent routing built into Istio. Now let's come back here and let's do the 30-30-30 version, rename. Now, typically we would have only one of the services or maybe two of the services running at a time, but it's fun to be able to play with it. So here's that third, and so we can see that we get sometimes red stars and sometimes black stars and sometimes no stars. That was cool. Let's dig into some of the dashboards that come with Istio. Now, if I'm looking at these dashboards, I can say Istio CTL dashboard dashboard. Typing is hard. Prometheus. Now this cluster was just started a moment ago, so we probably don't have a whole lot of details here. But let's take a look at one metric. Here's all the details associated with that metric here in Prometheus. Now this is interesting. This is the raw Prometheus data, but we probably want to level up a little bit and look instead at the Grafana dashboard over the top of it. So let's switch over to Grafana. And now we can see the Grafana dashboard over that Prometheus data. Now we do have some built-in dashboards here. So here's some Istio dashboards. Let's take a look at the workloads. Now in this case, we don't have a whole lot of work running in our cluster. We can see the times when I turned it off and turned it back on. But we get great analytics into the metrics inside of our system. Let's take a look at the Istio control plane. Yep, our control plane looks like it's doing well. It's using a little bit more disk. The CPU spiked a little bit, so I may need some additional horsepower in my Minikube cluster. But we can get great visualization into our Istio cluster. That's really cool. Let's look at Jger. Istio CTL dashboard Jger. Now Jger is a great Istio CTL dashboard. Spelling it correctly would help. There we go. This is a great way of being able to visualize our system. So we can see that our Istio ingress gateway calls to our product page. That goes to our details page. We also have our reviews page that goes to the ratings page. This is that network diagram where we can map the content as it actually happens. Now we see 97 requests coming in here, 79 went this way, 80 went this way, and only 52 went to the rating service. That makes sense. When we were using version 1, it didn't need to call the rating service. But when we've used version 2 and version 3, it did. Well, this is interesting, but let's zoom in a little bit and take a look at the Keali dashboard. As we look at the Keali dashboard, once we're logged in, I'm going to flip over to the graph. And this one is the one that is a little bit temperamental. So let's refresh the page a bunch of times because it's showing live traffic. I love this dashboard where it shows the network diagram. Here's our product page, and our product page reaches out to the details service, and that hits the version 1 of this container. The product page also reaches out to the reviews service. Now in this case, we were using all 3 services, but we can see that version 2 and version 3 actually reach out to the rating service, and the rating service forwards off to version 1. Well, if we switch over from version 1 to version 2, we should see this traffic increase, and eventually this node will drop off completely. As we flip over exclusively to version 3, we'll be able to see this traffic. Did that deployment go okay? Is it routing the way that we expect? That's where this Keali dashboard is really cool. We can see these virtual services that replace Kubernetes' native services and see the routing rules baked into the service discovery piece inside this dashboard. And there hasn't been traffic in my cluster for a while, so now it's showing me all these idle nodes that have not connected to anything. So that was really cool. We got to tour through both Linkerd and Istio. Linkerd focuses on a really elegant startup experience, and so we can see how we can get started really quickly with Linkerd. Now, oftentimes when we need to go beyond what Linkerd provides, we need to pull in extra plugins. By comparison, Istio is the kitchen sink where we can turn knobs on and off, and we got to see a lot of different experiences inside of Istio, a lot of different dashboards, and also a lot of virtual services being able to route in different ways. Are there any questions here on the demos, things that we saw in Istio or in Linkerd that we'd like to dig into more deeply?
I'm not seeing any questions yet, but if any pop up, I'll definitely shoot them your way.
That sounds perfect. So let's turn off Istio demo. Let's turn off the Istio demo and focus back in on when we would use a service mesh. What did we see in a service mesh? Well, we started with the crawl phase. Because we can observe, secure, and control all of the content within our, all of the traffic, both east-west and north-south traffic within our cluster, we could start getting really interesting things like monitoring, logging, service health. When we move from crawl to walk, now we get intelligent routing. We were able to do A/B channels and interesting things, A/B channels and A/B tests and beta channels. As we get from crawl to walk to run, now we get that network topology diagram where we can see how our traffic is actually flowing in our cluster. That is really cool. I love that it shows us exactly what's happening in the cluster, not what we think is happening in the cluster. Did we spin up a rogue container? Is that container reaching out into all the other containers trying to infect them? That's a good thing to see in our network topology diagram, as well as in our Grafana dashboards and Prometheus logs. Zach Butcher highlighted nicely some of the things inherent in Istio control plane, or in a service mesh. A service mesh has a control plane, and Zach highlights that here. If it doesn't have a control plane, it's not a service mesh. Now, don't we already have a control plane in our cluster? Don't we already have, well, the Kubernetes control plane? Yes. On the left, we have all of the details associated with our Kubernetes system. We have the control plane where we have etcd and the API server and various content associated with those control plane machines. Then we have the worker nodes, and inherent in the worker nodes, we have the kubelet, the kube proxy, we might have cAdvisor. All of this content is in addition to the workload that we're doing in our pods and containers. We're going to add to that the service mesh. Now, the service mesh has a control plane, things that create these certificates and validate their trust chains, things that keep track of the mechanism of routing and understand when a container should or shouldn't be routed to. We have the mechanisms of being able to connect from those sidecar proxies into this control plane. And then finally, we have those sidecar proxies alongside every other container. We just doubled the number of containers running in our cluster. If we're just trying to include a service mesh purely to check the checkbox, then we may have failed ourselves. There is a non-trivial amount of compute cost associated with running twice as many containers. Now, these sidecar proxies are probably a lot smaller than the big Tomcat Java applications that we're running inside these containers. So maybe the compute isn't twice the amount of compute, just twice the number of containers. Maybe it's 1.4 times the compute workload. But it is a non-trivial amount of compute add, and so we do need to provision that additional compute inside of our Kubernetes cluster to be able to handle the additional needs of our control plane, of our service mesh. If we're not ready to spend extra on our service mesh, then a service mesh may not be a great fit. Let's dive into that a little bit deeper. A service mesh is great at doing that observe, secure, and control processes, where we can watch all the traffic flowing between all of our services. We can create policies that regulate that traffic, and we can ultimately secure the traffic between each container without needing to change our code to make that happen. Observe, secure, and control. When should I use a service mesh? A service mesh is great when we need to separate and regulate and secure traffic going between containers. If we have high trust workloads like PKI or PCI, where we need to take that PKI information or the credit card information, we need to make sure that that is very specifically separate in our cluster. We'll create a service mesh. We'll create policies that only the known containers that need to can access those PCI or PKI containers. By comparison, we might have untrusted workloads. Maybe we're running workloads for others. Those probably need to get segregated as well. Now, we want to generally reach for namespaces in this case. Kubernetes namespaces are organizational. They are not security boundaries. Yes, I can't schedule something in somebody else's namespace, but once I do schedule something in my own namespace, that container can reach out into any other container in the cluster by default. A service mesh allows us to create those lanes. Perhaps we're creating a multi-tenant environment where each tenant is granted one namespace. We can create those very specific swim lanes with our service mesh to ensure that that tenant can only operate inside their namespace. By default, we think of namespaces as security boundaries because they are launch security boundaries, but they're not operational security boundaries. A service mesh can be that operational security boundary. So if I need security in depth, if I need to be able to route all traffic between all containers over HTTPS, this is a really elegant way to do that because I can do it without impacting my applications themselves. The applications route everything through those sidecar proxies, and the traffic between the application and the sidecar is within that local network inside that pod. So there's no unencrypted traffic flowing across my cluster. That can be a really nice thing to have. Finally, if I need advanced networking, like an AB channel, an AB routing scenario, or a beta channel, if I need that advanced scenario routing, then a service mesh can be a great way to achieve that. Now, these are some of the places where a service mesh makes sense. If I need to be able to observe, secure, or control traffic flowing in my cluster, either east-west or north-south. Should I pull in a service mesh? Well, do you have these needs? If you don't have these needs, a service mesh's additional compute costs may be enough of a downside to say, no, I really don't need a service mesh. But when you do need it, when you need to be able to do mutual TLS between your containers, when you need to be able to create those connection policies, a service mesh is a perfect solution for being able to take that additional level of control. This was really fun getting to show you service mesh in all of the details. If you're watching this video later, hit me up on Twitter at rob_rich. And these slides are available right now on robrich.org. For those who are here live at the conference, what are your questions? What are your thoughts? What did I miss?
Well, Rob, while we're waiting for questions to come in, I had one myself. Before you started talking about performance impact, that was the #1 question I had. It had some great benefits. Everything that you were talking about seemed wonderful, but it looked like it would come at a pretty steep performance impact. And when you were talking about roughly a 1.4 x performance hit whenever you're enabling this, is that a rough estimate? Do you see some service meshes are more or less of a performance impact than others?
I do want to clarify a little bit. This is additional compute content. From a performance standpoint, it's probably a lot less impact than that. We are computing certificates and validating certificates, but it's not like all of our requests will be, 50% slower. Our requests themselves will probably be roughly the same speed. I bet you won't notice the performance impact at all. You'll just note that you need, well, more compute power to pull this off. Thanks for clarifying there.
We've got a question coming in from Carl. It says, how wide is adoption for service mesh?
How wide is adoption? The example that I found is this one, and I think it's really cool. F-16 fighter jets have a Kubernetes cluster on board, keeping track of all of the different controls and metrics and dash dials. And it's a Kubernetes cluster running that plane. So they wanted a service mesh to be able to control the traffic between all of those containers running inside the plane. They were debating, do we accept the licensing with Istio, or should we go for Linkerd because it's a more favorable license? I'm not sure which one they chose, but it was really interesting to see a service mesh in an airplane.
I've
How
heard of some
widely
crazy
adopted
things
it
running in an
is it?
airplane.
I would expect that a lot of organizations that want to hit that security checkbox pull in service mesh really early. I'm not sure if that's the best choice, but I suspect that you'll find pretty wide adoption. Once you graduate to understanding what a service mesh can do, you may want to wait until you have those needs before you pull it in.
Speaking of understanding what it does and needs, we have a question here talking about moving pieces, microservices, service architecture. It seems like a service mesh would be the best security practice. If security is your only goal, would a service mesh still be right for you?
Exactly. Because it gives you that mutual TLS between the containers with a trust chain, a service mesh can be a great security product. Now, is it the only product that can do mutual TLS? You might be able to find a product that is not a service mesh that just does the mutual TLS part, or maybe you can bake in the certificate validation into your application as well, and maybe get a little bit lighter weight experience. But I love how service mesh kind of abstracts that away from the applications so that each app developer doesn't need to worry about it. If security is your only concern, then I think service mesh can be a really elegant solution, provided you can handle that additional compute cost.
We've got someone typing. It's an excellent, he said that's an excellent explanation.
Perfect. I'm glad that worked.
All right, was there anything else, Rob?
No, this was a lot of fun. Hit me up on Twitter at Rob_Rich and let's continue the conversation. Grab the slides right now at robrich.org. Thanks for joining us, everybody.
Have a great day, Rob. Thanks for talking.
Yes.